So we've used these inequalities before when we were talking about numbers. So if I said like 3 is less than 5, that would be a true statement. Okay, so I've made statements like that before. Say 3 is less than 5. Now I could not say things like 3 is less than 3. That would not be true. That's where we need the equal to. Same thing here when I do greater than. I could switch that and say 5 is greater than 3. Those two statements basically say the same thing. 3 is less than 5, 5 is greater than 3 says the same thing. So keep that in mind, because sometimes we keep the x on the left side, sometimes it ends up going to the right side. And so in that situation, we need to be able to read it. We always basically solve it or make statements of it regarding to x. When we added the line, we said that adds the equal to. So I could have that same statement, 3 is less than or equal to 5. But what that now allows me is I could say 3 is also less than or equal to 3, where that would not have been true before. So that equal to allows me to include that number. Is that okay? And then greater than and equal to, yes, I can say 5 is greater than or equal to 3, but now I can also say that 5 is greater than or equal to itself. So that includes all numbers and itself. When we're talking about x, x stands for some number we don't know. So our first statement down there where it says, and you got to read it, it says x is less than 5, means that our answers, our values of x that are going to be our answers, are going to be any number less than 5. Like what? What would be some numbers less than 5? 4, right? What else? 3, 2, I like it. 1, 0. All those negative numbers, right? 0. What about 4.5? See, 4.9. See that also? This doesn't just include whole numbers. This includes decimals and fractions, and anything less than 5 gets included. Does that make sense? So keep that in mind, because I have taught this before, and I had a student go, if you got the answer, x was less than 5, he'd literally start giving me a list. 4, 3, 2, 1, ... And I'm like, you're missing all the decimals, all the... So what we do is we graphically can write this answer. We graphically can show the answer and show that it is anything less than 5. How do we do that? Well, we start with a number line. And we start by putting a point at 5. But be careful, because there are two different points that we can use. If you are comfortable with the open point and close point, that does not hurt my feelings, but I'm going to show you something that's going to basically last longer. And it's going to help kind of the more complicated part of this, and that's going to be writing the expression in, let me make sure I do it right, in interval notation. Okay, and I want to talk about that too. That may be more than we're using at this point, but that's something you should be introduced to in an introductory algebra class, which this class combos into that now. We are now in introductory algebra concepts, right? Okay. So with that in mind, what we would do is we would say, what type of point do we use? You can use an open point that doesn't hurt my feelings. And then we have to know, where do I shade? Well, the direction less than would be to the... And notice that would be the numbers you were saying. 4, 3, 2, 1. Everything to the left of that 5. I am fine with that. What I would encourage you to do is to use this parenthesis symbol facing the way that we shade, and it means the same thing. Some of you are like, I don't like that. I get it, but it has a purpose. Okay? So when it's not equal to, we will use a parenthesis in both of these. And when it is equal to, we use this bracket, and that means including. And that's going to make interval notation a lot easier to understand. And that's something I'm going to want you to be able to do in this class. For instance, let me show you. If I wanted to write this answer as an interval, what is the lowest number x can be? Well, we shaded left forever. Is 0 the lowest number? No. It keeps going, right? In fact, it keeps going. We shaded the arrow there. That means it keeps going forever. And what we count forever in math, we count as an infinity. Okay? But this infinity is to the left of 0. So I'm going to say the minimum here, the minimum value it's going to be is negative infinity. X can be anything negative forever. Negative 10, negative 20, negative 1,000,000. All of those would be less than 5. Agreed? What is the maximum value? But it doesn't go to the right forever, does it? It stops going to the right. So our max this time is what? It's just the 5. And so when I write what's called interval notation, we put two things. We put a minimum and a maximum. and then we use a symbol, either a parenthesis or a bracket. Okay, so we use a, I'm going to write this down, our interval notation. And so we do the min, comma, max, and we'll either use parentheses or brackets on each side of it. So either parentheses or brackets, depending on whether it's equal to or not. So this one will be negative infinity, comma 5. On the infinity, will we use a parenthesis or a bracket? It's confusing. You're like, I don't know. Well, what did the parenthesis mean? The parenthesis meant that it was not equal to, right? And we started using brackets when it did equal. So let's think about infinity. Can you ever equal infinity? Can you ever have infinity? Doesn't make sense, does it? So whenever we use an infinity, we will use a parenthesis. Always. Whenever I use an infinity, we will use a parenthesis. Why? Because you can never equal infinity. What symbol will I use on the 5? Will you tell me? Did it equal the 5? See, it didn't, did it? And this is where it comes in handy, because whatever symbol I used on the 5 is the same symbol I used down here. Because why did I use a parenthesis up here? Because it didn't equal. So what symbol will I use down here? Because it doesn't equal. So that's where using an open and closed dot makes it actually a little more confusing. Learning to use that symbol here makes it easier to track that symbol down here. Does that make sense? Okay, let's keep going. I know this is the first time some of you have seen the whole interval notation. Depending on where you're going, I know in our intermediate algebra classes, we use the symbols a lot. Okay, we use this notation a little bit in statistics, but not as much. Really, we use this a lot in that pre-calculus direction. And I don't know where each of you is going, so we are covering it. Okay, depending on who you are, you may or may not be using this for the rest of your life. That's okay. Okay, you're allowed note cards on certain things, and so you don't have to memorize all this. And my goal is at the end, you go, okay, this should make sense. Okay, let's keep going. How is this next example different? What does it say? X is? That line adds the equal to, right? So I'm going to have this number line, and I'm going to put a point at 1, 2, 3, 4, 5. And going down the table, less than or equal to said, what kind of point will I use? Either a closed dot is fine, or a bracket. This is when we use the bracket, is when it's equal to. And here I'll change colors just to make life interesting. The equal to makes this symbol either a closed dot or a bracket. Now, if you're not sure which direction to face, I always have the interval face the direction we're shading. In this situation, since we're doing less than, I still shade to the left. And how is this answer different than our previous answer? How is less than 5 different than less than or equal to 5? What can we include now that we couldn't last time? Yeah. Yeah. I'll get to that. This is the example I'm doing right here. That's going to be another example. So sorry about that. So we've had first example, second, and this will be our third, and that will be our fourth. Does that make sense? Oh, sorry. So the question is, again, compared to the first example, what is different this time? What does that bracket tell me I can include now? The 5 is now part of our answer. See, 5 would now be part of the solution. So starting at 5, going left forever. How would I do my interval? What's the minimum? How far left do we go? Negative infinity. We go to the left forever. What is our maximum? How far right do we go? We go to the 5. What symbol do I put on the infinity? See who's paying attention. Let's make sure. It's all right. Can you ever equal infinity? So you always use what on infinities? Always the parenthesis. What symbol will I use on the 5? Why is that a bracket this time? You can equal the 5. See the difference? The next one says 5 is less than or equal to x. Here's where some people get themselves in trouble. They'll put a point on 5, 1, 2, 3, 4, 5. They'll put a bracket, and they'll say less than is to the left. I'll give you a hint. This is wrong. You're like, but it's a less than. Less than is to the left. Well, no. Yeah, you got to be careful. I did the bracket, so I did the equal to. The issue is shading to the left is wrong. You're like, why? It's less than. No, let's pick a number to the left of 5. Pick like the number, how about 0? Is 5 less than or equal to 0? See, we just shaded and we thought 0 was one of our solutions. Is 0 one of our solutions? So you will not shade this to the left. It's wrong. You're like, then you lied to me. No, I didn't. I said if it says x is less than, we shade to the left. This doesn't say x is less than. This says that 5 is less than or equal to the x, which means the x is bigger. X is bigger than the 5. And so when I look at this, I keep track of this and I go, oh, the x is greater. I'm going to shade that not to the left, but to the right. If that bothers you, then you need to start learning how to rewrite these and put that x on the left side. So this saying 5 is less than or equal to x, if it bothers you, then you need to know that is the same as saying that x is what? Is x less than the 5? Where's the mouth open towards? See, this says x is bigger. And so when I go down here, x is still going to be, these two things say the same thing. In both of these, the 5 is the one being pointed at. If 5 is less than x, that means x is bigger. If the mouth is open towards the x, that means x is still bigger. It's still pointing at the 5. These two things say the same thing. Does that make sense? So if you don't know to shade that one to the right, then you need to learn how to rewrite these by putting the x on the left side. And when we go to solve the actual inequalities, you may want to just keep left on the x side, and that might make your life easier. That's a choice, and I know some people that do that. We won't always be able to do that, but that's a solution for a lot of the questions. Okay? Interval, how's this one different? What's my minimum? How far left do we go on this number line? See, this time the minimum is 5. What's the maximum? See, this time we go right forever, and right forever means we have a positive infinity. And we don't have to put the positive on it, but our max is going to be, I heard it, infinity, right? So how would I write that interval? Minimum, comma, maximum. What symbol do I put on the 5? What symbol do I put on the infinity? Always a parenthesis. Does that make sense? A lot of people go, well, the first one has a bracket, the second one gets a bracket. No, you can never equal infinity, so never put a bracket on it. Can we keep going? This is really all the big new stuff. The rest of it, the solving and stuff, should more or less be a review. There's a little element to it, but this with the table that we got at the beginning should outline everything new with the inequalities. Okay? So if you can wrap your brain around this and you've gone through the solving equations, this should be a very easy way to finish up this section. Okay? Let's keep going. How am I going to solve an inequality? I'll give you a hand. I wrote it on the board. Oh, I skipped one. Keep me honest. I'm a dang liar sometimes. Sorry. Thank you. This one will be quick. This is, and they'll have you do this, and this will be, and the reason I give this example, we've done our fractions, so we should be kind of savvy with this by now. When you plot negative 3/4, it's negative, which means it should be to the left of 0. Where? Between? See, a lot of people will go back and put it between negative 3 and negative 4. And that terrifies me. They're like, well, it's got a 3 and a 4, so it's between 3 and 4. It's not, is it? So if you're confused by that, that's where you put the 3/4 in your decimal form, and it becomes negative 0.75. See, that's not between 3 and 4, is it? It's between 0 and negative 1. In fact, a little closer to the negative 1. And so I'm going to put a little line there, okay? Greater than means from there we're going to shade to the greater's to, see, now I got some of you gun shy. X is greater means it's to the right, okay? And is there an equal to sign? So what symbol will I use? And I'm okay if you put an open dot if this is the practice paper that we get, but the idea is that the parenthesis is going to make our intervals a lot easier. Okay? What is our minimum this time? Negative. Yep. With what symbol? Right? And then the max you said was to the right forever or positive infinity. With what symbol? This time they're both parentheses. Any questions on that before we continue? Before I try to jump ahead to the next example. Okay? All right, let's keep going. I love now I'm like super conscious that he's going to be totally in the background the whole time. That's funny. All right, so going back to what I was trying to get all excited about earlier, how do I solve an inequality? Yep. This is what I'm doing is I'm putting the screen up and I'm talking. I'm trying to waste the time while you write. Okay? The good news is if you know how to solve equations, then you know how to solve an inequality. The process is the same. Let me show you what I mean. Could you solve that equation? Gosh, I hope so. That was the assignment we turned in, right, already. We undo the adding, I heard, by subtracting the 3, so that k equals, nope, so that k equals about 6, right? How would I solve the inequality? Well, the inequality creates our two sides of the inequality, and we can draw that line just the same. So that if I have k plus 3, I can solve for that inequality, I can solve for that variable by subtracting 3. The process doesn't change. Sort of. There's one exception. We'll talk about it. We'll see why in a second. Okay? Well, I already wrote it on the screen, but that's our next example. I'll show you. So instead of k equaling 6 here, what do we have? K is greater than. Good. Which we could graph. Let's see. 1, 2, 3, 4, 5, 6. Greater. Greater would be to the right with what symbol? Good. So what's the interval? What's our minimum? What's our maximum? What symbol on the 6? What symbol on the infinity? You guys are learning this already. What's the only difference when I solve an inequality? I put it right there. The only exception is if we ever divide or multiply, not by just anything, whenever we divide or multiply by a negative number, everything flips. Now, a lot of people will say, just flip the inequality, and that's fine, but I want you to see that everything flips. And this is a good reason for understanding why this occurs. And so our next example, how am I going to solve that for k? I'll give you a hint. The same way we would solve it if it was an equation. Here's one bad habit, and I encourage you not to do this. I have had people that had teachers that taught them just put an equal sign there and solve it in the end. But the problem is sometimes things flip, and so that can get you in trouble. So I don't recommend putting an equal sign there. I get why they told you to do that. We treat it like an equal sign, but just keep the inequality because it's going to make a difference, especially in this question. Okay? So how do I solve for k? Thank you for not saying adding. That would make me really sad. I've only had a couple people as I've been working through that were trying to do this. Why is this utter nonsense?
Because you're multiplying.
You can't undo multiplying by adding. That makes sense, right? This is utter nonsense. And they're like, oh, but look, they go away. No, they don't. Those are not even like terms. That's not going to do it. So don't do that. We undo multiplying, you said, by dividing. And since it's being multiplied by a negative, we divide by a negative. And we had plenty of practice on this already. So what happens now? What happens with the negative 15? It changes, doesn't it? It's not just 15 divided by 3 is 5. It changes from a negative to a... It changes, doesn't it? What happens to the k? It changes, doesn't it? It was negative. And dividing it by the negative, that k is now. So what happens to the inequality? Why? Everything flips when we multiply or divide by a negative. Why? Short answer is because it's wrong if you don't flip it. That's a lame answer, but that is true, right? But why does it? Everything flips. So wait a second. Does that mean if I subtract, I'm going to flip everything? No, because not everything's going to flip. The only time it flips is if we multiply or divide by a, then everything flips. All the numbers that are negative turn positive. All the numbers that are positive turn negative, right? You with me? Mm-hmm. All right, so when we graph this, here we got a number line, right? What point are we starting at again? At 5, right? And this says 5 is greater than or equal to k. So what would be the direction we would shade? Right? And then I know I got some of you gun shy again. Just check a number on each side. Would 4 be true in here? Is 5 greater than or equal to 4? 5 greater than or equal to 4? It is, isn't it? Then that's the way I shade. That's one way of doing it. Is 6? Check the 6, because some of you are going to go greater is to the right. Is 5 greater than or equal to 6? See, that should stop you, right? But if you're like, I just don't like that, then that's fine. Then learn to take the answer at the end, put the k at the beginning, put the 5, and keep it pointing at the what? Whatever it was pointing at before. It was pointing at the k, so make sure it points still at the k. These two say the same thing. And I would accept either. I don't know how the homework might require you to put the variable first. I'm not sure. But you need to know that these both say the same thing. What symbol do I need to put on the 5? There you go. And we've done I think we've done this one already, so I'll keep going. Okay? How do I solve it when there's variables on both sides? We've done this before when it was an equation. And guess what? The rules didn't change. Here's my biggest concern. Are we going to bring those together and make 5k? That needs to stop. I know a couple of you are doing that. We have never combined things across an equal sign before. Don't do this. Don't do that with an inequality, okay? So when I look at this, how do I get that k on one side? Do you want to subtract the 3 or subtract the 2? I generally like to do the smaller of them. Keep things positive. And if I do it to one side, do it to the... Okay, what's left on the left side? 7 plus k greater than or equal to... Are we done solving it? No. How do I get that k by itself? If I do it to one side, do it to the other, so that k is greater than or equal to... And oh wait, you can, put that in your calculator. -5 minus 7.
So why doesn't the symbol change on this one?
Great question. We subtracted, right? We subtracted. Did everything change? This was negative. It stayed negative. This was positive. Right? Not everything changes. When does it all change? Whenever we multiply or divide by a negative. And a lot of people want to flip it when we subtract, but that should be your thing going, everything didn't change, so it doesn't all flip. And when will it all change? Whenever we multiply or divide by a negative. Does that make sense? You good on that? I'll tell you what, that's a common thing, and that's not a big deal. Okay? But let's catch it now. So what does this mean? I'm going to put a point out on negative. And I'm not probably going to count like freaking 12. I'm just going to say somewhere to the left here is -12. Make that a 12. Greater than means I'm going to shade this to the greater numbers are to the right. With what symbol? Equal to as what symbol? A bracket. So what is our interval? What's our minimum? Well, lowest. How far low do we go? So I see -12 and I see infinity. We always start with the minimum. Okay? If you put the maximum first and the minimum second, it's wrong. I'm not freaking out. This is the first time you've seen it, okay? Now in intermediate algebra and definitely in a calculus or pre-calculus, these have to be in the correct order. We don't get to change stuff, okay? So what is our minimum though? That's what goes first. What is our maximum? What symbol on the negative 12? What symbol on the infinity? You have just basically learned solution as an interval without me having to write out the notes. We figured it out. And what is it? Two numbers between the parentheses or brackets with a min and a, okay? When is it parentheses? Yeah, basically when there's not an equal to, right? It's either greater than or less than. Basically, it's not equal. Or we use parentheses whenever we use what symbol? Either a negative infinity or a positive infinity will have parentheses because you cannot equal negative infinity or positive infinity, right? When will we use a bracket? Whenever it is greater than or equal to or less than or equal to. But the key here is what? When it has when it is equal, we use brackets. Does that make sense? Okay. And that's why the open and closed dot doesn't hurt my feelings, but it makes the intervals go a lot smoother. Fair enough? And you can bet on our next practice, and I'm not going to give it to you today, I want you guys to actually focus on working through the pi, okay? But our next practice, I'm going to be having you put some of these intervals on there. I need to see that you can do that, okay? All right, let's keep going. You can solve this if it's an equation, then you should be able to solve it if it's an inequality. What was our first step for solving equations? There was an S word. Simplify. And that included several things. That included with a D. That included with a C. And that included with an I.
Inverse.
Nope, that's our second step. That's okay. We isolate the variable. And then step 2, after we simplify, we solve, and that's with the inverse. Okay? Solve with inverse operations, which is basically the way I described it, was PEMDAS backwards. SAD-MEP, however you want to do it. Okay? SAD-MEP, it's backwards. PEMDAS. These are the jokes. I'm sorry they're no good. That's all I got. So looking at this example, is there any distributing to do? Okay. Is there any combining like terms? Which ones do I combine? I'm not touching this side. That has to be on the same side to combine, right? So those, what is negative x plus 2x? Less than. On this side, what are my like terms? 2 minus 5. And bring down that 3x. Am I ready to solve this? No distributing, we combine like terms. Let's isolate the variable. I've got two variables. They're not on the same side. What will I do? You get to make a choice here. I'm the type of person that I want to deal with things that are positive, which means I'm going to subtract the 1x, smaller of them. Somebody else in here is not liking when I put the variable on the right side. That's the thing that's messing them up. If you're that person, then I would subtract the 3x. Why? Because it puts the x on the left side. And it just means you're going to have to deal with more negatives than the rest of us. But it doesn't mean it's wrong. Does that make sense? So by vote here, would you rather subtract the x or subtract the 3x? I heard an x. Okay, most of us are leaning towards the x. So you want to deal with positives? That's fine. That leaves us with 7 is less than what? Now we're ready for step 2, which is to solve. Doing what first? So that 10 is less than 2x. And when I divide, 5 is less than x. For fun and giggles, what if somebody had subtracted the 3x? Would it have flipped at that point? I'll give you a hint. No. Because do we multiply or divide by a negative? Then we would subtract 7. Would it flip at that point? Did we multiply or divide by a negative yet? Still haven't, have we? But our last step would be to divide by the, this is the key word, divide by the, not just the 2, the negative. That's exciting to me, because what happens when we divide by negative? Everything that's negative turns, and the inequality also. By the way, do these answers say the same thing? And they wouldn't have unless we'd have flipped it at the end. So why do we flip it? Short answer is because it's wrong if you don't. That's a lame answer. Okay? But it's true. If you don't flip it, your answer will be wrong. Does that make sense? And we could graph it and we could do the interval on this. So I'm going to focus more on the solving. Can we keep going? Questions, concerns? This was just if somebody really likes to put the x on the left side. Did it change the answer? So you got choices. Step 1. What can we do to simplify first? This time I have a 5 that distributes to the k, to the 3. Does it keep going? Don't do it. It's a trap, right? It only distributes across the group. So we have 5k minus 5 times 3 is 15 minus 7k greater than or equal to. The 4 distributes to the what? 4k minus 12, good job, plus the, leave the 9 alone, right? Am I done simplifying? We said distribute, we said like 5 minus 7. Do not put a little plus 7 and plus 7. These are on the same side. I heard negative 2k minus 15 greater than or equal to, on this side, negative 12 plus 9. I think it's negative 3.
Yes.
Are we done simplifying? I still have 2 variables, right? How would we isolate it? I'm not going to do it both ways this time, so you choose. Do you want to add the 2 or subtract the 4? Most people are saying add 2. That's fine. So you like to deal with things that are positive. I get that. Right? We all like the positive energy. But then you got to be careful at the end with the variable on the right side. Okay? And now we're done with simplifying. Now we can solve this by doing what first? PEMDAS backwards. Is there any adding, subtracting? We deal with that first. We undo the subtracting by... Notice I'm not worried about the 15. The 15 is not what's happening to the variables, not what's happening to the k. We undo what's happening to that variable. So we had 3 to both sides. Negative 15 plus 3 would be negative greater than or equal to... Did I flip anything? What's my last step? Undo the multiplying by dividing. Am I going to flip it this time? Did we multiply or divide by a negative? So then I don't flip it. So we got negative 2 greater than or equal to k. Or k is what? These two say the same thing. Please be careful with that. Because in both of these, I would start at negative 2 with a bracket and shade it to the left. So be careful with that. Okay? That's probably the most common mistake. If you don't like that, then always put the variable on the left, or at the end, learn to rewrite it on the left. Either way, you've got to be careful with that. Okay? I think we're almost done with the inequality, so just be patient with me. Yep, that's our last one. This is more or less, and this is not as big a deal. There will be a couple of these that pop up every now and then. We can have inequalities where there's basically three sides to it. So we're comparing x to two different sides. Okay. Some books will have you split it. I don't like to do that, and I find when people split it, they open up a lot more mistakes. So what I do is I just treat this as like it's an inequality, but it has three different sides to it. Well, how do I know what to do? Well, I'm solving for x. What's happening to the x? I heard subtracted, and those are the only things happening to the x, right? So that's what I'm going to focus on undoing. I'm not going to worry about the 4 and the 10. I want to undo what's happening to the x. So how do I deal with that subtracting? That'll get rid of it, right? But what I do to one side, but there's freaking three sides, right? So we do to all three sides. I don't know if this pops up in the homework yet, but this is something I like to introduce here. What is 4 plus 5? Less than or equal to? Less than? How do I undo the multiplying now? By? And if I do it to the middle? To all. So this now says that 3 is less than or equal to x, right? Which is also less than. How would I graph this? It's really not that hard, actually, because this basically says that x is between two numbers, isn't it? It's between the 3 and the. In fact, the first one says that x is greater than the 5. I know that's a less than sign, but the x is the bigger of them. X is bigger than the 3, and it's less than the 5. That's what this says. X is between the 3 and the. So 0, 1, 2, 3, 4, 5. This right here tells me x is greater than the 3. That means from the 3, what direction do I go? But it should have stopped. If you caught that already, that's good. If not, just wait a second. The second one says that x is what? Less than 5 would be from the 5 to the. So do I just shade the whole line? No. What you do is that x is only between them. It's only the overlap. And I love this because what did the blue and the yellow make? Hey, we learned art in math class today, right? But the idea is what? It's only between. This is the only place that should be really shaded, is the overlap. Because x is only the numbers that's in between those two. Does that make sense? By the way, what symbol on the 3? Equal to says bracket. What symbol on the 5? No equal to has a parenthesis. And I love this because as terrifying as that was, the interval is a piece of cake. What's the minimum? What's the maximum? What symbol on the 3? What symbol on the 5? Check with your neighbor. Make sure this makes sense. If you have questions, now's your chance. Yes, sir. No, you answered it yourself, but the 5 doesn't have an equal to, so that's why a lot of times I think they're afraid of doing this. A lot of the homeworks I see that they'll keep them the same. I just like to stop and think that they can be different. Okay? Any other questions? That's it? I did a really good job. Y'all understand this, huh? Okay. They're like, right now I do. Oh, it'd be like that. I'll give you a second. So this is the idea of translating. When we say 6 more than, that tells me that I'm what? That, oh good. An inequality would be is more than. So if I said is more than, sorry, thank you. If I said is more than, that would be a greater than. Or if I said is less than, that would be a less than. Okay? So this doesn't have that is, does it? I'll give you a hint. If you got $5 and I got 6 more than that, how much do I have? How'd you get 11? You took the 5 plus the... When you say 6 more than here, we are adding to what? The quotient of a number and 2. Well, that's terrifying. What does quotient mean? It means divide. I feel like we've had these phrases before. Yeah, it's been a while ago. That's okay. Quotient means to divide a number. That's weird. They didn't give us a number. That's our variable. That's what we don't know. So this says divide that x and by, right? Divide that x by 2. Can you do that? How would you divide x by 2? Some of you are going to do this. X divided by 2. I wouldn't do that. It's not wrong, but the idea is it's easier if we just make it a fraction. This is one of those times you're like, what, a fraction? Yeah. This says x divided by 2, doesn't it? Deep breaths, I know. Now that's just that part right here. That's this. How do I do 6 more than that? I'm going to add 6 to it. Technically this time it doesn't matter if the 6 goes at the beginning or the end, but it matters when we do subtracting. So I encourage you, the more than and less thans, we actually put it at the end. Okay? We're almost there. Ready for the last part? How do you translate equals? Thank you. 9. Welcome to words in math. Who'd have thunk it? Do you know how to solve this? How would you solve it? Inverse operations, right? Well, we will multiply by 2, but what do I do first? Remember, PEMDAS backwards says deal with the adding and subtracting first. So how will I deal with that adding? Do that first. And then to deal with the dividing, I would. Nobody knows. That's exciting. Then to deal with the dividing, I would. Everything by. You could have, on that one, multiplied everything by 2 to clear the fraction. If you're thinking of it that way, that is the way I discussed it. That's not wrong. Okay? It's just, I just thought of this as inverse operations. But if you want to clear the fractions first, that's a great skill. Okay? So what's left on the left side? X. On the right side? Is that okay? That's all right. 1 down, 8 to go. We're going to get through this. Eight more than the product of a number and 9 is 3. Okay. 8 more than the product of a number and 9 is 3. What is 8 more than? We're going to add 8 to whatever this mess is. What does product mean? We're going to multiply a number, some number we don't know. What do we put for some number we don't know? That's where we use the variables. So we're going to multiply that number and 9. How are we going to do that? That would be perfectly fine. If you want to put a little dot in the middle, 9 times x, that wouldn't hurt my feelings either. But 9x means 9 times x, doesn't it? But at the beginning of the sentence said we're going to add what to it? 8. So we're going to add 8 to that. What does is mean? Yep, that's just a complicated way of saying equals. So they could say equals or is or the result is, things like that, okay? How would you solve this now? Three minus 8 should be negative 5. Last but not least, so that x is equal to negative 5 over. If it needs to be simplified, simplify the fractions. Some of you didn't do that on the activities. You left like 10 divided by 2. Yeah, you know who you are. But this one doesn't need to be simplified, so just be careful. 2 down, 7 to go. How are we doing? I see a trail of tears on your papers. We'll be all right. That's all right. I can wait. Just say acres, acres, acres. Gamate. Or coffee break. That might be nicer. I don't know. It's not a swear word. Why are you laughing? I'm glad you thought that was funny. I don't know. Now you're glaring at each other. It's awesome. All right. A washer and a dryer cost $1,000. Cost of the washer is 3 times the cost of the dryer. What is the cost of the dryer? I don't know. Think we can figure that out? Can I scoot this up now? Or down, depending on your perspective? We have 2 things that we don't know this time, right? We have a washer and a dryer. So that means potentially 2 variables. If you want to use x, we can. Then I would use x and. That's fine, right? Or, since it's washer and dryer, maybe we could use. Why not? What is that first sentence telling me? If W is the cost of the washer and D is the cost of the dryer, their cost combined is $1,000. What does that mean? I can do with the W and the D. If I combine or if I add their costs, they should equal. Does that make sense? Okay. Now we are going to be going into like systems of equations later on with 2 variables. This is just an intro to that. And they keep it pretty simple. Okay. Our second statement says the washer is, help me translate that, W, good, 3 times the cost of the dryer. There we go. So what can I do when they do this basically is I can replace, I can substitute. I don't want to solve where there's 2 variables, right? So, but the good news is this. This tells me that W equals 3D, doesn't it? So do you see the other equation where there's a W? What can I replace it with? Because if W equals 3D here, then I can go over to this W and replace it with a. Any questions on that? What did that do for me, right? We had an equation with 2 variables. That was complicated. By substituting that, by replacing it, now we have an equation with 1 variable. Now there's 2 D's on there, but they're the same variable, right? So that means I can now solve this by what? On the same side? On the same side, they what? If they're on the same side, though, they just combine. What is 3D plus D? 4D is equal to 1,000. We had to do the multiplying by. So that D is? $200 what? Could we figure out the cost of the washer? Well, it said the washer was. So that means the washer is equal to 3D. We just figured out that D is equal to. Can I go to that D and replace it with a 250? What's 3 times 250? Does that answer also make sense? Because the one is 3 times the other one, and combined, how much would that be? Now, technically, all they wanted was the cost of the dryer, so that D was our answer. But we could take that a step further, and I like these, especially these ones, because they're not just throwing out stuff. At the end, the answer should make sense. The one is cost 3 times as much as the other one, and if I combine their costs, they're $1,000. Does that make sense? 3 down, 6 to go. Sorry, the text is a little smaller. What I will do is I'll read it for you. Sam rented a truck for 1 day. There was a base fee of $17.99, an additional charge of 88 cents for each mile driven. Sam had to pay $245.91. When he returned the truck, how many miles did he drive the truck? Dang it, Sam, I sent you out to drive a truck and you came back with a friggin' math problem, right? So what we have here, and we're not going to need to make 2 equations, what we have here is basically a total cost. And that's that we know that it costs $245.91. That's our total cost. What we have to do is we have to come up with an equation with that first statement to figure out how would you calculate the total cost, right? You rented this truck, how much are you going to pay? Well, you're going to start with the initial, or they call it the base fee. So that's going to be the $17.99. But that's not all you pay. You also pay, that's the cost for each mile, right? I'm running out with colors, but we'll make it work. The cost of each mile, you said the 88 cents. So I'm just going to pay only 88 cents. Now it's 88 cents per, and notice the miles are what we don't know, right? So it's going to be the cost of the miles times the number of miles. That's what we don't know. What are we going to put for the number of miles? That's the only thing we don't know. That's going to be on X or M or whatever you want, right? But the idea is that's our unknown. The rest of it, we can fill it in. What was the total cost? And that should equal the initial base fee, which was plus the cost of each mile, which was, don't put 88 here, right? That basically says I'm spending 88 bucks. Since if I'm dealing with money, if I'm dealing with all these as dollars, this needs to be 0.88 or 88 cents. Good call on that, right? Yeah, I wish I was charging people $88 a mile, right? But we're not going to do that. 88 cents times X. Could you solve for X? I'll give you a hint. We've done this before. Some of us are going to multiply everything by 100. That doesn't hurt my feelings. Do you have a calculator in your hand? You can handle the decimals then. And so I'm going to go through it that way. If you want to multiply it all by 100, if you did that all times 100, you would have 24591 is equal to 1799 plus 88x. Feel free to solve it that way if you'd like. I'm just going to do inverse operations because I got technology, which means PEMDAS backwards, which means I'm looking for SADMEP. I'm looking for the, is there any subtracting or adding? How do you undo that 1799? Subtract it over. We subtract it away first. Can you do that in your calculator? Question, sir.
So you wouldn't combine the 1799 with the 0.88?
No, because of the operations going on there, this is stuck with multiplication. You can't add before you deal with the multiplying. So if that was 1799 plus 88 plus x, then you could combine like terms. Okay? So what is 245.91 minus 17.99? It's equal to. Now how will I undo the multiplying? By. And how many miles did Sam drive? Even? That's awesome. How are we doing? So you're going to have these in the homework. Okay? Am I going to have an entire test full of these? No. You'll have an assignment full of these that I want you to practice through and work on. Okay? But what's going to happen is, what can you expect on the actual test or on the actual quiz? Should reflect what's on the practice quiz. Okay? Yes, there will be some word questions. No, I'm not going to have 9 of them. Okay? 8 maybe, not 9. Okay. You don't think that's funny? Can I scoot this down? All right. Yes, no? Going? All right. Well, Jane has a job. I know. In this economy, it's a good time. Transporting soft drinks by truck. Her truck is filled with cans that weigh 14 ounces and bottles that weigh 70 ounces. They have a combined total of 960 cans and bottles. Let X be the number of 14-ounce cans. Write an expression for the combined total weight of the cans and bottles in her truck. I will tell you right now, this is a great question, but this would be is prepping you for stuff we'll be doing in upcoming chapters. Okay, we can do stuff with these, but for now, I'm just wondering, can we set up, right? Can we set up an expression for the total weight of the cans and bottles in her truck? Does that make sense? Okay, and I wish they were more specific, but they want, they should put in or with a single variable. Okay. We have two things. We have cans and we have bottles. They already told us to call the cans what? Good. So what should we call the bottles? Sure. Why not? Right? It says, so X is the number, this is the, I'm missing the T there. Oh, wait. So this is the weight, and this is the B is the bottles, this is the weight, and it says that there are 960, what does combined mean? So this right here is one equation. Right? What can I do with the X and the B? What does combined mean? If I add X plus, if I add the number of cans and I add the number of bottles, it should add up to, there's our first equation. What I want is a weight in the truck. How will I get the total weight? We did this kind of with the last one when we spend money, right? We did the cost times how many we had. The cost times how many we had. This is going to be similar. We're going to take the weight times how many, the weight of the cans times how many cans there are. The weight of the bottles times how many. And if we combine them, that should give us a total weight. I'm going to write out what I just said. We can take the weight of the cans and multiply it by the number of cans. We can take the weight of the bottles and multiply it by the number of and to get a combined weight, I'm going to take those two and I'm going to what? There you go. Do we know what the total weight is? They didn't give it to us this time. We're not solving for that. So we'll just say the total weight is equal to, do you know what the weight of the cans is? What did it say? 70, right? Times, do we know how many cans? We don't know, but they said to call that X. Plus, do we know the weight of the bottles? It was up a little higher, but hopefully you wrote that down. The bottles weighed, uh-oh, we messed up. The cans weighed, and the bottles weighed. So we messed up on that. The weight of the cans was not 70, it was what? Plus, the weight of the bottles was times B. This is an expression for the combined weight. This is not what they want. They wanted it all in a single variable. We have x's and we have b's. But we have two equations here, right? Can we replace the x's with the b's, or can we replace the b's with the x's? That's what they basically want us to do. Does that make sense? So take our first equation. Could you solve that for b? Could you get that b by itself? How would you do that? B is equal to? Agreed? What can I do with that now with the other equation? If b equals 960 minus x, what can I do in the other equation? Do you see a b there? What can I put in its place? What is that going to do now? Now it's all going to be x. Now it's all going to be one variable. So the total weight is going to be 14x plus 70 times, what's b? And I'm actually fine with that. They probably want you to simplify that. But that, we have it all as one variable. How would you simplify that?
Distribute.
So if we distribute the 70, I'm going to need your help because these numbers are a bit terrifying. I just need, what's 70 times 960? I think I got like 6720.
67,200.
Yeah. Minus 70x. And then I would combine. So basically t would be equal to 67,200. 14 minus 70. Is that minus 56? I'd be fine with either of these answers. But I'm guessing they're probably going to want you to simplify it. I get that that question is a little harder than the other ones. But once again, not on the test. Fair enough? Can we keep going? Five down, 4 to go. Like I said, if we need to stop, I may stop here in a little bit. We've got 10 minutes. We'll see how far we get. The sum of three numbers is 133. The second number is 8 more than the first. The third number is 3 times the first. What are the numbers? We have the option of calling the first number x, the second one y, the third one z. You can do that, but what I'm going to do is I'm going to make an argument. Let's make our lives easier. Okay? If I call the first number x, the second number y, the third number z, you all just didn't like the last one. You're like, we have freaking 2 variables, and here we have 3? That's not cool. But then don't do that, because look at what they do right here. They tell us that the second number is 8 more than the... See, they're comparing the second to the first, aren't they? And then the third is 3 times the... They're comparing both the second and the third to the... So basically, I don't have to write 3 different variables. I can write them all in terms of x as the first one. So the second number, or I can say y if you really want to, is, how would you do 8 more than the first? What's more than? Yeah. So rather than make it an x and a y, I'm going to call it x and the next one x plus 8. Does that make sense? And rather than call the last one z, I'm going to replace that and say it's just 3 times the first, or it's just 3. So rather than have 3 variables, now I can say if I added the first plus the second plus the third, they should all equal what? What's the first one worth? Plus what's the second one worth? See, I don't want a second variable, do I? You didn't do it. You're right. So you just call it x plus 8. See how that's easier? One variable. Plus the, what's the third one? This makes this much easier to solve. All of these x's are on the same side, which means what's x plus 3x? Back to inverse operations, 2-step equation. What would you do first? So 5x is equal to about 125. And last, so that x is equal to 20. Did we find all the numbers? Not yet. We found the first number is 25. What's the second number? What's 8 more than 25? See how this works? And what's the third number? Three times that, 3 times the first number. So 3 times 25. Are these answers right? Because they should total what? 25 plus 33 plus 75 should total 133, does it? See, that one wasn't so bad. Look for what they're comparing to. When they say more than, less than, that than tells me I'm comparing everything to the first. Call that our x, and then write equations with only one variable. When you can. 6 down. 3 to go. You ready? At a movie theater, child admission is $540, adult admission $860. 156 tickets were sold for total sales of $1,047.20. How many tickets were sold that day? Child tickets. Pardon me. Thank you for calling me on that. That's why I actually like taping this in front of a live audience, because I'm a liar and I make mistakes. So thank you. Don't be shy. Do we know how many child tickets were sold? What can we call that? We can call it X. That's fine. Do we know how many adult tickets were sold? We can call that. What is this 540 and this 860? Good. You got to get these cost models down. It should make sense. When we know how many we sold, it's the amount times the cost. It's basically the amount of X times the cost of X plus the amount of Y times the... And if I do that, if I multiply the amount times the cost, the amount times the cost, and I add them all up, I get a total cost or total money brought in or total, but this is one of the models that you need to be able to set up with the word questions. When they start talking about costs and amount, cost times amount equals total. Fair enough? Do we know the amount of X tickets, the amount of child tickets that were sold? But we can call that what? Do we know the cost of those? Do we know the amount of Y? Do we know the cost of Y? Do we know the total cost? You with me on this? We're missing one thing. We've used every number up to the 156. What's the 156? And that's another model we need to know, and it's not a difficult one. If I take the amount of X plus the amount of Y, that just gives me a total what? Yeah, not a total cost, a total amount, right? So basically it's just what? X plus Y equals, we have two equations. I could solve these if we only had one variable. We can. Take the simple equation, take the bottom one, and solve for X, or solve for Y, or solve for one of them, right? So take that bottom equation, get that X or Y by itself. How would you do it? Subtract which one? All right, I heard subtract Y. So you end up with X is equal to 156 minus Y. Perfect. What can I do with this now? The top equation, do you see that X? I can now replace it with that. So I now can say 156 minus Y times 540 plus Y times 860 is equal to 1047, 20. We need a little more space, but we can solve this now. We now have an equation with all one variable, right? How will I solve it? What's the D word? All right, let me move all this. I'm going to save this for the next one, so don't stress out about it. I'm going to distribute backwards. I hope that's not bother anyone. We've done that. That was in our simplifying. We had one that distributed backwards like that. So if that bothers you, move the 5-4 at the beginning and then distribute the other way. Okay. But what is 5.4 times 156? I need a calculator. I want to finish this quickly.
5.4 times 156
Mm-hmm.
842.4.
Perfect. Minus 5.4 times y would just be 5.4y. Plus, if you don't mind, I'm going to rewrite this as just 8.6 times y. Are we done simplifying? Same side. Combine like terms. That should give me, I think, 3.2. Is that right? Can I get an amen on that? All right. Two-step equation. What would you do first? (3.2y) is equal to 204.8. Last step. By y equals what? Awesome. All done? Wait. What was the question? What was the question? Did we just find how many child tickets? Yes. No, you didn't, you damn liars, right? You just found y. You found the adult. Don't freak out. Look. Look, y is 64, and didn't up here, oops, I went too far, sorry. It didn't up here, we figure out x is 156 minus y, isn't it? So if there were 64 adult tickets, then what is 156 minus 64? Come on, answer this question. You're good. 92. There were 92 stinky kids at this thing. Does that make sense? Okay. The last two we'll deal with later, and that'll just be on inequalities. Good job, guys.